Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kisiedu. In this installment in the Developmental Mathematics series, I will discuss fractions, part 2, fractions of fractions. A prime number is a natural number whose only divisors are 1 and itself. In other words, a prime number's only factors are 1 and itself. By convention, 1 is not prime. The first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. As we discussed in the prime and composite number series, the fundamental theorem of arithmetic states that every natural number greater than 1 is the product of one and only one set of prime numbers. For example, 144 is equal to 2 times 2 times 2 times 2 times 3 times 3, or 2 to the fourth times 3 squared. There can be no other set of prime factors. Also, 1,260 is equal to 2 times 2 times 3 times 3 times 5 times 7, or 2 squared times 3 squared times 5 times 7. If two natural numbers have no prime factors in common, they are prime to each other, or relatively prime. A fraction is said to be reduced to lowest terms when its terms are relatively prime. Dividing the numerator and denominator of a fraction by the same non-zero number or numbers before multiplying is called canceling. To reduce a fraction to its lowest terms, write the numerator and denominator as the products of their prime factors, then cancel. Let's reduce the fraction 24 over 96 to lowest terms. In terms of their prime factorizations, the numerator and denominator become 2 times 2 times 2 times 3 over 2 times 2 times 2 times 2 times 2 times 3. Canceling, 3 2's are removed from top and bottom, and the 3 from top and bottom, leaving 1 over 2 times 2, or 1 over 4. Since the numerator and denominator have no common factors other than 1, 1/4 is the lowest terms equivalent fraction to 24 over 96. A compound fraction is a fraction of a fraction. To multiply two fractions, separately multiply their numerators and their denominators. The word of indicates multiplication. For example, half of 3/5 is a compound fraction and is the same as half times 3/5, which is equal to 1 times 3 over 2 times 5, or 3 over 10. The reciprocal of a number is 1 divided by that number. The reciprocal of a number is also called its multiplicative inverse. Multiplying any non-zero number by its multiplicative inverse gives a product of 1. For example, the reciprocal of 5 is 1 over 5, and 5 times 1/5 is equal to 1. The multiplicative inverse of the fraction 12 over 17 is 1 over 12 over 17, or 17 over 12, its inversion. The commutative property of multiplication says that the order in which factors are multiplied does not affect their product. Dividing a fraction by a number is the same as multiplying by the reciprocal of that number. So 3/5 divided by 3 is equal to 3/5 times 1/3, which is equal to 3 over 1 times 1 over 5 times 1/3. We can apply the commutative property of multiplication here and move the 1/3 next to the 3 to get 3 over 1 times 1/3 times 1/5. Since 3 over 1 and 1 over 3 are multiplicative inverses, their product is equal to 1, leaving just 1 times 1/5, which is 1/5. So 3/5 divided by 3 is equal to 1/5. To simplify a complex fraction, we can either multiply the numerator fraction by the reciprocal of the denominator fraction, or we can multiply the numerator and denominator fractions by the same non-zero number. Let's divide 3½ by 7/8. First, rewrite 3½ as 7 over 2, so that we have 7 over 2 divided by 7 over 8. Then multiply 7 over 2 by the reciprocal of 7 over 8 to get 7 over 2 times 8 over 7. The 7's cancel and both 2 and 8 are divisible by 2, so the fraction reduces to 4. Using the second method, again, first rewrite 3½ as 7 over 2. Then, since 8 is divisible by both 2 and 8, multiply both the numerator and denominator fractions by 8. Cancellations will leave us with 7 times 4 over 7, which can be rewritten as 7 over 7 times 4, which equals 1 times 4, or 4. For a visual interpretation of 4/7 divided by 5, we can take a rectangle and divide it into 7 equal-sized vertical sections, sevenths. We will shade 4 of them blue. These blue sections represent 4/7 of the whole rectangle. Now the 7 sections are subdivided into 5 equal-sized horizontal sections since we are multiplying by 1/5. We are looking at one of the 5 blue sections, which we will shade yellow. The yellow sections represent 4 of the total 35 sections, or 4/35. Complex fractions can be interpreted as the number of times the denominator is contained in the numerator. 1/8 is contained in 1 8 times, or you can say that there are 8/8 in 1. 1/250th is contained in 3 over 1 over 250 times, which is equal to 3 times 250 over 1, or 750 times.